Hello everyone, I welcome you all for the video lecture on data structures. The topic to be discussed is linked list implementation. What is a linked list? A linked list is a linear data structure where elements are not stored at contiguous memory locations. Instead, each element is a separate object called a node, and nodes are linked together using pointers. Let us look at its characteristics. Dynamic size, which can grow or shrink at runtime. Efficient insertion and deletion of nodes. It uses non-contiguous memory location. Each node contains data and address of the next node. It forms the basis for many advanced data structures. Why we need linked list? Linked lists are useful when we need a dynamic data structure where frequent insertions and deletions are required, and the size of the data is not known in advance. So this is how the basic structure of the linked list would be. A node containing the data, and then the next value represents the address of the next node. Let's emphasize why we need to evolve to the linked list concept. So when we observe the array data structure, which was previously constructed, arrays have a fixed size. Insertion and deletion require shifting of elements. Memory may be wasted. While initializing the array, we need to give the maximum memory size. So memory will be wasted, and dynamic data storage is difficult in the array concept. So the outcome is to identify the need for a better data structure. Let's define a data structure that grows and shrinks dynamically, allows efficient insertion and deletion, which utilizes memory efficiently, and which stores data sequentially without continuous memory. Thus, the outcome should be dynamic memory-based structure. Let's ideate. The possible solution is to develop a linked list. The idea is to store data in nodes. Connect nodes using pointers. Allocate memory only when needed. The benefits are dynamic size, efficient insertion, efficient deletion, better memory utilization. In the prototype phase, we have developed the linked list, implementing node structure, creating linked list to perform the operations of traversal, insertion, deletion, and searching. So let's look at the structure of a node. The structure of a node contains data and the next address of the node. So data is, it stores the values or the data of the node. The next points to the address of the next node. We have three types of list: singly linked list, doubly linked list, and circular linked list. In singly linked list, each node contains data and the address of the next node. The last node points to null. Doubly linked list, each node contains data, address of the next node, and address of the previous node. Circular linked list, let's define it. It is a linear data structure in which the last node points back to the first node head instead of pointing to null. So the characteristics of the circular linked list are: the last node links back to the head node. There is no null at the end of the list. Traversal can begin from any node, efficient for cyclic or repetitive processing. It supports continuous traversal without restarting. So let's look at the applications in round-robin CPU scheduling. In CPU scheduling, in round-robin algorithm, it uses the circular linked list data structure to store the value so that it is scheduled in a round basis. And then the circular queues. And we have multiplayer turn-based games. In those game applications, the multiplayer turn is a circular linked list so that one after using it, the other gets the chance. And then the music and video playlist. If we look at the music and video playlist, if it is stored in the circular linked list, then the last song which is played, after then the first song gets played. And then the traffic signal control systems, so that the order of the light will be red, yellow, and green, and again red, yellow, green. So it is a circular linked list concept. And let's discuss the advantages and disadvantages. The advantages are efficient implementation of circular queues. It is suitable for round-robin scheduling algorithms. It is easy for traversal from the last node to the first node. No need to reset to the head after reaching the last node. So disadvantages, when we look at it, the traversal requires careful termination conditions. It is more difficult to debug than a singly linked list. So infinite loops may occur if traversal is not handled properly. That's coming to the end of the session. Thank you.